All right, welcome back to number three. The last episode, just a quick recap. The last episode, what we did was we added a label, a text box, a button. As you see over here, label, text box, button, and then we add the whole click feature to the button. When you clicked it, we set the label text to that. In this one right here, we're going to focus on a little bit more UI design. So I'll show you right now why I mean UI design. So right now, when we actually make the screen bigger, the buttons and stuff stay. So when I blow it up, it all stays in the middle. In many cases we don't want that. We want an adaptive UI. We want a UI that'll breathe with the program. So when we shrink it, it goes away. We don't want that. So what I'm going to do is I'm going to show you a very basic technique on how to adjust the anchoring in the program so that way it'll fit what we want. So what we do is we look at many different variables. First off, we like the size, we like the position within the frames where it is. We like that the space is relative to the size, the top and the bottom. So we know that we like that. So the first question is which ones do we want to shrink and grow, and which objects do we want to stay the same? So what I do is look at, like in this case right here, I don't want this to shrink and grow because text is gonna, if I make it expand, if I make it shrink, it's gonna come all together. It's gonna grow too bad. I'm not worried about that. So I'm worried about locking this location into where it is. Right now, we start from the left and the top left, and we go down to the bottom right. So right now in the top left, where it is perfect. So when I look at the anchor, I click on that label and I go to the anchor and it says anchor is top left. Perfect. Okay. So this one right here, I like the size of it because if I make the button grow, it gets too big, it starts to crawl into it starts to like bleed into other places, and I'll show you a very good example of that. So what I'm going to do is I'm going to anchor it to all three, the top, left, and right, and we're going to run it. So then when I actually grow this, when I expand it, you see the button becomes big, and it starts to get like just really weird, and that's not how I really want the button to go. So when I blow it up here, the button becomes really incredibly long, and we don't want that. We want the text box to do that, but we don't want the button to do that. So what we're going to do is this. We're going to actually change the anchor on the button here, and we're going to anchor the button because we like where it is in the top left. The top right. We're going to remove the word left. So we can either remove the word left here, or we can come here and just unclick that. So now, when I run it, I'm just using the F5 key to run, which is the same as clicking that button. Now, when I run it, and you see the button stays in the same spot. Problem is that it never goes away. I don't like that. So that's kind of one of the other things that we got to work on, is how can it not collide with others. So in this case here, we're going to actually tie this control right here. We're going to anchor this one, the text box. We're going to set the anchoring to all three. We want this to be top, center, left, right. And we want this one right here, hello world, we want to stay centered but on the bottom. We don't want it anywhere but the bottom. We want it to stay center on the bottom. No matter how big we make it, it's going to stay center bottom. So we're going to change this as instead of top, we're going to change bottom left, right. So when we set this up here, as we grow, notice that the button stays there and it overwrites that piece, but duly note that this box grows and the button never actually grows, but this hello world, it stays in the position it is on the bottom. It stays right. We've locked it into where it is. We didn't say center frame. We just said stay right where you are. We're going to lock you in on, we're going to anchor you on to the bottom, left, and right. Now, we can actually dock it to the center, to the bottom, and that'll actually dock that there, but I'm not a fan of docking them, so I always just say none, and I let myself go to where I want it to go. To make it always centered, trying to remember where that was. Actually, I think that's going to be code. I think we actually have to use code to figure out to make it center. I want to say that the label was the one that made us use code to center it. See, we can actually lock the location itself too. There's all kinds of fun little stuff that you can do inside of here. Modify, you can add padding to it. Set the tab index. Oh, the tab index is another thing. We'll actually play around with that in this video. Anyhow, we're not going to waste too much time on centering stuff because generally when we run it, it's going to be in the location we want for forms. Then you know, I just focus on really this piece right up here is keeping these in the same location and then allowing us to enter text. So then we had change label and change label, so that's fine. All right, so now let's actually add some more stuff. So let's pull this down here. I'm going to add another set. So what I'm going to do is I'm actually, because I'm going to copy this and paste this a bunch of times, I'm going to add a few more labels and text boxes. So instead of going here, going label, text box, label, text box, label, text box, I can just select these two right here just by highlighting them. Make sure that I can drag them. And then Control C or edit copy, whichever one you want. You can go edit copy and then right click and paste or hit Control V, paste them, and then move them as a group to where you want them to be. Remember, the good part about Visual Studio is that they snap into place and they don't let you get too close to the other object above it. See that space is always there. I can get within that space if I actually go and change the location in here, but I really don't want. I kind of want to keep what they say here, so we're going to do a couple more of these. Let's do 3, 4 of them. And now let's just do a bulk move. So highlight, move. Alright, so we're going to change this from enter stuff 1, 2. Then we'll just change it to label to 3 because we're not really worried. Sure, whatever. Sorry. 3 and then 4. So in the reason why where this would work is like if we're doing an address, city, state, zip. So actually, you know what? Let me do a better one. So address, city, because we're past the hello world part. So state, and down here. Is it there or did it go away? Oh, it's still there. And this is zip. Zip. Bam. And just because I'm crazy weird like that. Back. Good. And pull these over. And city, capital IC. See. You become a programmer when you actually do this for a living. That stuff just gets to be psychotic. It drives you crazy. All right. So essentially, what we did was I moved the button down to here. So I'm going to reset the anchoring on the button because I don't want it top right, and because I moved it, it changed it. So I actually want the button to stay bottom center. Let's now see if I add the top one here. Watch this trick. This always happens to me when I do stuff. The button grows and disappears, and it stays where it's completely where it's supposed to be, and that just drives me absolutely crazy. So making sure that your anchoring is correct is going to help your application to be as good as it can possibly be. So So, all right. So now, in this case right here, we have multiple text boxes that we can enter crap and stuff into. And when we hit the button, of course, it's only going to grab address 1 and change that label for us. So it's going to get that. Now, what we want to do is, here's another piece, is, and this is a good example. When I type in my address of 1234 and I hit tab, it goes right to this button. I don't want it to go to this button. I want it to go to the next one down here. I want it so when I'm up here and I hit tab, it goes to city. When I hit tab, it goes to state. When I hit tab, it goes to zip. And then when I hit tab, it goes to the button. And that's the order that I wanted it. So back in the program here, when we click on the box, you'll see the tab index of 2. And then we click on the city, we see a tab index of 5. But when we come back here, we see a tab index of 3. We want to change it, so this is 2. This is going to be 3. 3. This is going to be 4. 4. This is going to be 5. 5. And this is going to be 6. 6. But we'll also notice that these right here, these actual labels have a tab index as well. So what I like to do is I'll move the tab index way out to like Never Land. So that way I don't ever have to worry about them, because yeah, you'll never tab to a label, so actually having a tab index on a label is kind of crazy. There is uses for it down the road somewhere, but I still have not found one yet, so I'm not worried. Anyhow, so now I'm going to run it with the new tab indexes. And I'm going to type in my address. I'm going to hit tab. It goes on the next box. Tab again, next box. Tab again, next box. Tab again, back to over to here, and bingo. And then when I hit tab, it goes all the way back to the beginning. So the tab index is set right. Now, a little bit of history on the tab. The reason why tab comes into play. For programming back in the day, before we had a mouse, the tab was probably one of the most important keys on the keyboard, of course, other than spacebar, because the tab would allow you to go through forms a lot faster than clicking with the mouse. Now people have become more mouse-oriented. The mouse is kind of like, I see people typing and clicking, type, click, type, click, type, click, and in the back of my mind I'm going, the tab button works. Just use tab. It's going to make your life a little easier. Okay, so now we have multiple text boxes. We have a hello world label, and we have a button. And when we click the button, it pulls the first one, changes the label. Now, in this case right here, we're going to actually pull multiple text in, and we're going to change that label to represent an address, or an address of sorts. So when we double click on the button, it'll bring us back to the button code that's already there. So it's not going to rewrite the dot click again for us. When we double click on the button at any time, it'll actually bring us back to the code that we already have written. So we've commented out this piece right here. Let's comment out this piece because we're going to actually change it up. So now, of course, in Visual Basic, as you know, that this is the comment out thing anyhow. And then in C#, it's actually 2 slashes. Java, it's 2 slashes. HTML, it's slash. It's some craziness. The good part about Visual Studio is that no matter what you're writing in, if you do highlight it and you hold down Control, you press KC, it knows how to comment that code based on the type that you're writing, and it will actually comment your code out for you. So you don't really have to remember that. All right, so in this case right here, what we're going to do is I'm going to do this 3 different ways. 1 is going to be done, 1 and 2 are going to be done the way that we've already showed you. And then the third way, we're actually going to use a sub that's going to give us a little bit more of an example as to what the power of subs and functions are. So in this case right here, what we're going to do is we're actually going to define the 4 different types. So we look at it, we got address, city, state, zip. So let's go dim address as string equals nothing, dim city as string equals nothing, dim state as string equals nothing, and dim zip as string equals nothing. All right, that's one way to do it. in Visual Studio, well, Visual Basic, it allows us, one of the things that programming nowadays allows us to do is to create empty objects and empty variables. And empty variables mean that they're not defined until we add a value to it, and then it inherits that value. So essentially, if we create a box and I put water inside that box turns to a glass. If I create a box and I put a cat inside that box turns to a cat carrier. So by defining, right now what we're doing here is we're actually telling the compiler that address is a string and that it's empty. So we can do another way to do this, to define all these as empty strings, is to dim address, city, state, and zip as string there. And of course that's going to throw up an error because of this right here, because it's already defined. But now what that does is that actually just defines all those variables as a string. And we can also, another way that we can do it, and this right here is just a string with no value. This is a string with a blank value. So if I call address dot type, it'll tell me string. Address dot value, it'll tell me nothing. It'll tell me just a blank string. Whereas if I actually say address dot type value here, or text, it'll say the text doesn't exist because it has nothing as value, which can throw up errors. So, but another way to actually do it is to do it like this right here. That's just defining them as absolutely nothing. So this type of definition right here says that zip is just an object. It defines it as an object, and it's going to stay an object until it inherits whatever value we assign to it. So it becomes an object, and then if I make it a string, if I send a string to it, it becomes a string. If I send an integer to it, it becomes an integer. If I send a double to it, it becomes a double. The problem with using this method is good and quick, but the problem with it is that we don't know what type it is beforehand. So if we're calling a database and we call a call back from a database row, a.item, a.item1, or database row dot item 0, it becomes a varchar, or varchar, whatever you want, variable character, varchr, and chr, sorry, and that is a specific type in its own. That's kind of a string, but if the database is set up as an integer and it sends back varchr or varchar, then we won't know. We'll handle it in the code as an integer, but it's not an integer. So by actually defining it here, by using this definition, this type right here, this is our way of actually defining what the variable is before we actually give it an actual text. So now you'll see that it says zip as string as opposed to object. It's safer to do it this way for beginning programmers. It's going to be safer for you to do it this way, to actually define it here. But as you go on and you become a better programmer and you get more used to this stuff, you'll find that you're doing a lot more empty variables or objects. You create a lot more objects and just let them inherit whatever it is, and then just handling the inheritance later. One of the problems that I have a lot is DB nulls, database nulls. Like if I call a database and there's a null value inside of it, I'm trying to handle it as an integer. I say, well, send me back an integer. And it says, well, that's a DB null, not an integer. It's a completely different type. So then I actually have to, is this a DB null first? And then if it's not a null, okay, then send me back an integer. It's kind of the way that programming works, and you'll learn this stuff as you go. This is not stuff that we pick up right now, not anything we're supposed to know the second we look at a program. It's little things that you'll learn as you go on, as you make the mistakes. It'll come to you. So in this case right here, we're just going to address, city, state, zip as string, and then let's just assign what they are. So address equals, and let's take a look. Which one is it? All right, so it's text box 1 right here. All right, so text box 1, text box 2, 3, and 4. All right. So text box 1 dot text city equals text box 2 dot text state equals text box 3 dot text and zip equals text box 4 dot text. All right. So now when we run the program, city will then become text box 1. Oh, we're going to show you a little bit of an advanced debugging trick. All right, so now, right now, at this moment, we just assign those variables to those strings, and we're hoping that it works. We're not sure whether it's going to work. One cool thing about Visual Studio that it gives us that we didn't have before is the ability to debug and stop the program at any point we want and see what's happening. And we can do that by, on this gray strip over here, clicking on the line. And see this little red stop point? What that's going to do is that's actually going to create a breakpoint for us. And that breakpoint is when the code reaches this point, it's going to stop right here. And it's going to come back here. And then we'll be able to hover over any of the variables that have been set at this point and see what they are, as well as step through our code and step into our code. So let me show you how that works now. So what I'm going to do is I'm going to run the program, and this is really cool. I wish I had this way back in the day because it saved me a lot of logging and error logging and craziness. So, and I'm just going to type in some basic stuff here. So because we're not actually looking for a fully qualified value, I'm going to actually just do 3 and 4, and then hit that. And now you see it stopped here, yellow. What I can do is then from this point here, I can hover over any of these, and it will tell me, see, address equals 1. When I look at it, it says 1. And then city should say 2, I2. And then text is nothing yet. So if I actually look at the program, if I come back here, where are we? Let me go to it. Oh, dang it. On multiple monitors, you'd be able to see it because it would show you on the second monitor what the program looks like. On this monitor, this always stays up front, so we can't walk through it. But now we're able to actually step into using F11 or step over using F10. Step over and step into. There are two different things. If we're calling a function or a sub that we've created, step into will run every single line. It'll step into that function and run line. Step over F10 will step over that function and execute that function without having to stop at every line and tell us what it is. So when we're using these right here, in this case right here where we're not calling a function, we can use either or F10 or F11. If we're running a function and it starts at the beginning perfectly fine, it runs through, but by the time it gets to the next line down after the function and it runs into an error, we want to step in and see what the error is inside the function. So here I'm just going to use F10 to step over, and we'll see state now becomes 3, zip has no value, F10, now zip has a value of 4. Okay, so 1, then here's a good one, I2, 3, and 4, and F5 to keep going, and there you go. Now you see the I2s right there. So that was absolutely correct. Our variables did grab the values here, so now we can stop and say that this code is right. We know that it's correct. Now, the next piece is to build the code, is to build the string that we're going to change this to. So I'm going to do this one way, and then I'm going to show you how to do this two ways. First way, we're actually going to build a variable for it. We're going to call this full address equals address, then use the and symbol and quotes, and then the and symbol again. Now what I'm doing is I'm saying address, whatever address is, then concatenate a space to the end and concatenate the city, and then use the and symbol and now put a comma there, the space, and then the and symbol, now state, and then the and symbol. Now the and symbol here allows me to pin two strings together, allows me to put two strings together. So if I did, dim yeah, if I did equals yes, space and no. This yeah would actually equal this. It would say yes, no. That's what this is. This is the product that we get from this code right here. Is the product of this. So the and symbol allows me to combine strings, to concatenate stuff to the end of the string. So we have city state. We want to put a couple of spaces in here, and then we're going to go and zip. Now, when I do this, is actually this address is an object, is declared as an object. So if I actually come down, if I do this right here, we're going to see it's now an object, right? But because I'm assigning strings to that object, it then inherits the string. So I don't have to say as string. That's useless code, being that I'm assigning a string to it already. So I can just get rid of all those bytes and not have to worry about it, because when I hover over it, it's already going to be declared as a string, because it knows that we're sending strings to it, so it's going to be by default a string. So now, then the next piece we could do is just grab this text up here, label1.text, just like we did up there. Label1.text equals label1.text equals full. Let's do full address. Bingo. And there we go. So now when we run this, we do 1, 2, 3, 4, go. Run past this. All right. And you see 1, 2, 3, 4. So you see that we built it and we've assigned it correctly. So this is one way of doing it. The second way of doing it is kind of the same idea as what we used up here, is that instead of doing this, we can actually do, text box 1. And so let's just copy this right here, because we're going to use the same spacing. Text box 1.text. This is going to be text box 2 dot text, and text box 3 text, and over here text box 4 dot text. So we can actually do this right here. So let's comment out this control. We're going to comment that out for now. We're actually going to use these again. So I'm going to show you a different way to do them. All right. So now when I go, 1, 2, 3, 4 there, we run this. Just skip right past it. 1, 2, comma 3, 4. Yeah, so that's right. Okay, so this is the short way of doing it, because we're not worried about saving off the address, city, state, and zip. Where I'm worried about saving off the address, city, state, and zip now. So what I'm going to do is I'm going to actually uncomment this, and we're going to comment this out, because we're going to use a function that'll do it for us. And the function is actually going to be a little bit fun. So we're going to call it function build address, and we're going to go by val. So there's two pieces when we build the sub or a function. We pass in a couple of values, and we pass in a couple of values. So what we're able to do when we pass the values in, we're able to predefine what the values are. So before we predefine what the values are, I should be doing this. I should do this in its own video, but that's okay. We can when we call them in the function, we call them by value or by reference. So by value means that whatever it's sent in as is what it is. By reference means that we can make a reference to it, or we can actually change it here ourselves. I always use by value because I want what they're sending us to be what it is. To me, it really doesn't matter. I mean, you can even not use that, and you can just do like address as string. So you can do your by val, by val address as string, by ref address as string. But for me, I always use by val. Just I don't know. I've been just friendly doing that. I like doing that. That's something weird. All right. So then we're gonna actually do another one. Let's do by val. But once you do by val once, you're gonna do by val for all of them, or once you define the by val or by ref, it can be either by val or by ref, but you have to do it for everyone. You can't just say, that one's by val, and let's do city as string. It's going to give us an error still. Even though it's technically correct, it's going to say that, it needs to be defined, like right here. See, an end function. So if I come here, I get rid of this, and then go like that. End function's there. We should have got an error here, but I don't know. 2017 might have fixed that. Oh, look at that. Hey, you see that? Right there. Fix for this. Huh? Oh. Either way, anyhow, so I like to use the by val. I may be old school, but sure. I guess they fixed that in 2017, so we'll do by val and then state as string, by val zip as string. All right, so now the function. Now if I go here, I go dim. Let's actually do this. We'll actually change label 1 inside of here. So, wait a minute. All right. I'm just doing something. I'm going to change this to sub. All right, sub address. Sub. All right. All right. So actually, what I'm going to do is I'm going to create the sub here. And we're going to show you kind of how the sub works, because the sub doesn't return anything. So in this case right here, where we're just setting the label, we're just going to use a sub to start, and then I'm going to go through and use a function afterwards. So I'm going to use a sub, and then I'm going to just set the sub to equal. I don't even know why I deleted all that fun stuff I showed up there. No, this right here. This is the one I want. So what's happening is when we call it, even if I call it with anything, so here's going to be an example here. There. Call this there. So now down here, after I set them all up, I'm going to build address sub, and I'm going to pass in whatever variables I want up here. And it doesn't matter what they're named up here. Once we get inside of the sub down here, these are the values that we're going to use. So I could pass in, see address. If I call address 123 and then I go city, state, zip, this address 1123, whatever, gets changed to address in here. So whenever I refer inside to address, it pulls in whatever's in the position. So when we look inside the function here, we think of it as position 0, 1, 2, 3. So then when I say position 0 is address, position 1 city, position 2 state, and position 3 zip. So then when I call address, it refers to address here, which pulls in that one. When I call city, it refers to this city here, which pulls in that one. State, state, state. So even if I change these all to be like city 1 2, state 1 2, zip 1 2, city 1 2, state 1 2, zip 1 2, then we'll just actually change them up here. Sorry about that. City 1 2, state 1 2, and zip 1 2. So even if I change them out here, it does not make a difference what it is inside of here. It just matters that when we call this, we're passing the address. We pass in 0, 1, 2, and 3. We pass in 4 variables in this specific order, and then we're going to read them in this specific order too. So now, when I actually run this, we're going to stop here, and I'm going to tell you, and I'm going to show you what I mean by the step over and the step into. So we're going to run this. Actually, we're not, because it does have errors right there. So let's back out. So we're going to run it, and I'm going to show you the step over. So we're going to do 1, 2, 3, 4. And if I actually turn the number lock on, 1, 2, 3, 4. All right. So when I hit this, and now if I'm going to step into, which is F11 step into, right here, step into, it's going to come down here and it's going to run the code for me. So then once we get out, it's already been done. So now, let's set this as an X. Now I'm going to step over it using F10 to step over. It doesn't actually go into the function, it just steps over it. It does exactly what we need, but it doesn't go into it. It steps over this whole function, So that way there, I can just get past it, because a lot of times we'll have 6 or 7 functions in here, and we already know that they work. We just care about the beginning and the end. We don't care about what happens in the middle. So just stepping over it stops us from having to go through, that 100 lines of code just to know that it already works. So we can just step over that function. And now we'll go back and we'll see that we built it. So let's run this. We'll run this example again. We're going to use the address 123 test 1 state, and then zip, and then 1 2 3 4 5, and then change label. So now when I run this, you're going to see that we've already these variables 1 2 3 test 2 state zip, step in, and now label.text equals hello world, and we're going to change it to the actual qualified city state. So let's F10, let's F5, we're going to run through, and we'll see that it actually changed it down there now. So we use this sub that doesn't return anything back. So being that this sub doesn't return anything back, all it does is just runs the code, it does what we want it to do, and it's over. It doesn't return anything back to us, so we don't have to worry about saying, well, did that sub actually work? No, because we don't care. That's what subs are for. Subs are there just to do the work and not tell us anything about it. Functions, on the other hand, functions actually return back to us different stuff. So we're gonna do the same code right here, but we're gonna use a function instead. So what we want to do is we're going to actually declare a variable. So we're going to dim return 1 as string equals that. So we don't even actually have to do as string, because we know that whatever this returns, we can do as string here and allow this, and then what's going to happen is return 1 is going to be a string. Now if I comment out this, return 1 is an object, but what's returned by this function, as you see as string down here, is a string. So if I actually get rid of this piece right here, that then turns into an object again, because we're not sure what's being returned by this function right here. So in the function we can actually say as string, and then this tells us that our return has got to be a string. We can do as boolean, boolean, which is your true or false, and then that will actually change this right here, this variable, because it's not declared. It's going to be returned. This is going to return a boolean, so this is going to actually inherit the return boolean. But we don't want that. We actually want a string, because we're going to use this function to actually build the city, state, and zip files. So with this function, we're going to pass in city, state, and zip. Let's go a little bit different. For the sake of simplicity, we're going to build the return to equal this. So no, I don't want to do that, because that's crazy to actually pass in and then just return the same stuff that you passed in. So in this case, we're going to change it up a little bit. So we're going to comment out this code right here. What we're going to do is we're actually going to change this function to allow us to pass in 4 text boxes and actually spit back out what the address itself. So we're going to change these strings to text boxes, and we're actually going to call this right here. So when we call the function itself, instead of passing in what we've already set up text from the text box, we're actually going to pass in the text box itself. So text box 1, this is a little bit of a little tiny bit of an advanced concept, being that we're actually going to pass in the text boxes that we know. So thinking of these text boxes as an actual object, when we pull the code from the back, we say text box dot whatever. So we can actually pass the text box object in. We don't have to pass text. This right here is just pulling the text from it. So saying whatever it says, this is now whatever it says. This is going to send to the function itself the full text box. So now within the function, we're actually going to, we have the text box coming in, not just the text. We have every aspect of the text box. So what we're going to do is we're going to actually verify before we build the string. We're going to do a little bit of a verification process here. So first things first, we're going to build the string. This is going to be our return string. Return s as string equals nothing, just because I'm having fun like that. So return s as string. And yeah, sorry, I just wanted to check, make sure that we were still recording and see where we're at. So return as a string. So now we're going to check each one of these boxes to make sure that they've got text. We can use recursion, such as a for loop or an actual process itself to check it. What I like to do, I like to build a check function, and I call it chk, and I say t as text box. And then what I do is I just I return a boolean. Return. This is way off topic, and this is a little bit more fun for me at least. So return boolean. Sorry, as boolean. Wow. Holy Lord, what am I doing? As boolean. All right. So what I'm going to do here is I'm actually going to go t dot if. So we're going to use an if statement. If statement is just like anything when you look at it. If the light is red, stop. If the light is green, go. If the light is red if the light is green and there's somebody pulling out, then do this. So if, then else is really the way to think about ifs. You can really get deep with ifs, and you can get nasty with them, and there's better ways to handle multiple outcomes instead of using an if statement. But for now, I'm going to do an if then else. So if t.text equals nothing, it's blank, then we're going to do t.background color equals red, equals drawing dot color dot red, and then we're going to return false because it's not correct. And now we're going to do the else. So else mean that if t.text equals nothing, do this. Otherwise, if t.text equals something, we're going to set t.background color to equal drawing dot color dot white, which is the color that it already is. Well, we can just do default. Well, just say white for fun. I'm not worried about the technicalities of, oh well, it's not really white. It's I am. I'm strange about that. Window. Damn it. Trying dot. Yeah, we'll just use white. Whatever. I'm not worried about it. But we're not going to return true here. The reason why we're not going to return true is because we don't want to. Well, we don't want to return. Actually, yeah, you know, we will return true because we're going to do a little bit of a trick in the other way. So yes. So right here, if t.text is nothing, return false. Otherwise, return true. Change it to white, return true. So what we're going to do is then back in the code here, we're going to pass each one of these text boxes that are brought into us. We're going to pass it to this function to check to make sure it has text. So the reason being is that we want to say, all right, so here we go. We're going to set up our own little Boolean value up here. We're going to call this dim go equals false. Well, go equals true just for fun. All right. If go equals true, then we're going to check our address box. So chk address. All right. Okay, so, and we're actually going to say, go equals check address. So what we're going to do is if go is true, which it is, we already know that in the first one. That's perfectly fine. Then go equals check address. So then we're going to pass in the address box, and it's going to go Okay, so if address dot text equals nothing, red, then return false. So go will then equal false, or go will equal true. So then we're going to come down here, and we're going to do that 4 more times. We're going to do that for city. We're going to do it for state. And we're going to do it for zip. So at any point, if any of these return false, so this is true and that's false, go will not equal true, so it won't do that. Go won't equal true because go is false, false. It won't do any of these, it'll just stop. So as long as these are returning true, which means that there's text, it'll go and check the next one. So it'll just stop checking at the point wherever it turns red, and then it won't work. Then we won't worry about it. Actually, you know what we're going to do? Watch this. Fudge. Okay. This is a little, yeah, this is a little nastier way of doing it. So this is the right way. This is what we should do. Who cares if go is true? So that's one way of doing it. The problem with that way that I just showed you, and this is a good learning experience, is that if it stops at city, when we look at the form, it'll only highlight city as red. It won't highlight anything below it. So it won't tell you that 3 out of the 4 boxes don't have text. It'll only tell you the first one that doesn't have text, and then stop. We want it to tell all the ones that don't have text. So we don't care if go equals true or not. We're not worried about that yet. What we are worried about is if in the end go doesn't equal true. So here we're going to do go equals true, then go equals whatever is returned by here. Now this is going to tell me right here, see, it doesn't return a value, which is perfectly fine. Return nothing, and it's not going to let me do nothing. I don't think it will. Will it? Okay, good. Return nothing, but then that equals nothing, and that's, yeah, you know what? I'll just leave it blank. All right. So this is technically incorrect, but it works. It absolutely works in the program as well. Visual Studio wants every function to return something, and if a function doesn't return anything, it throws up an error. In this case, I don't care if it throws up an error, that like this kind of an error, that's fine, whatever. But what I care about is that if the text is nothing, that it returns false. So go is true. If there's text there, go is going to stay true. False, then it's going to check this one, say that's false, check this one, say it's false. And then in the end, if go equals true, then we're actually going to process the text boxes. So there. So that's kind of one of the little fun things that we can do, and to verify that there's text in all the boxes, and highlight red which ones don't have text in it. And once we set go from true to false, it stays false. So no matter what, once we get down here, if it's true, then do this. Else, you know, label one.text equals error found. So there. All right. So now here we're going to actually process this. So what we can do is we can say that address, city, state, and zip we know have text in it. So we can then actually no, sorry, I did the wrong way. Return. All right. You. All right, it's done. Type a little bit too much. All right, so then return equals address dot text. So we'll do it like this right here because this is pretty much it. Let's just change this, and then this here, there, this here, this here, and this here. Now we could have easily said down here, set these variables up here, but the problem is that if this doesn't have text in it, I don't want to set the variables because then we're just wasting memory. You know, then we'll have to go and we'll have to clear, do garbage dump at the end, and then clear up the memory because we now have variables that have been defined as to equal nothing, to equal blank, when that's just useless waste of variable memory space. So what we're doing now is if go equals true, we're going to build this string to equal what it is. Otherwise, we're going to say error found. So so now at the very end here, we're just going to return underscore s. All right. So now we're going to return back to whoever calls this and passes in all the stuff right. We're going to return back whatever the string is. So if go is true, we're actually going to build the address and return that. If it's not, we're going to actually return error found with an exclamation point. So then up here, back in our button click, where we did return 1 equals build address when we pass in the text box, down here, return 1 is either going to say the address or error found. So what we want to do is we want to test it here. So we say if return 1, we're going to say does not equal, which is this right here, equal error. And let me just grab the right text here. Error found. Error found. Then, label 1.text equals. Actually, you know what? Yeah, this right here is if we care if the error is found. So, in the case that we're working on right now, we don't care about that. We're gonna actually do this. We're gonna do label 1.text equals return 1. Return 1, because we're going to return error already, error found, so we don't have to worry about looking for it. This right here, when I would do this, is if we're going to return values and I don't want to use what we return, I want to make it look prettier. So I'll say if this equals that, then return 1, else label 1.text equals there was an error with your stuff, right? Fix it. So if I want to make it look nicer, which sometimes programmers will return stuff like this, error there or error found, they'll return behind the scenes type of error alerting, and then they'll actually have a code like this to make your error look nicer. But in this case where I've already returned what I wanted to say, I don't need to do this, so I can just comment this out. So I'm doing it this way right here, where I'm using a variable, and then I'm just putting the variable here. Another way that we can do this is to actually skip the variable and just use the build function here. So what I'm going to do is I'm going to do label 1.text equals just the build function. And this right here is going to do the exact same thing that these two do. So let's go ahead and just take a look at what it does. So we're going to run through this one since that's a lot of code and there's a lot of stuff that was done here, so it may get a little confusing. Let's look at what we did. So address is going to be 123 test, and then I just hit the number locks again. 123 test, and then city is going to be city, state is state, zip is 12345, and we're going to hit change label. And now what it's going to do is it's actually going to call out to the function build label. So it's going to pass in text box 1, and this is actually the full text box, not just the text, but as you can see, it's got the auto scroll, auto sides, got the colors, it's got everything. So this is actually the text box value itself. So I stepped over it, which I shouldn't have done. Let me just come back here next time. Let's step into it. Yes, that's fine. Okay. So now, when we step into it, it's going to return our string as nothing. So it's just a blank string. It gives us go equals true. And then we're going to step into this once so we can see what it does. So we pass in the text box. So now we look at text box, t.text equals nothing. If it equals nothing, change the background to red and set false. But it doesn't because it has actual text. So color is white and then return nothing. So now go stays false. Why does it stay false? It should be false. That should be true. Alright, so what? Alright. We got a little bit of a slight little issue here, so let me just go equals true, and if text equals nothing, then red false. Otherwise, return nothing. Let's just try nothing just for fun. 1, 2, 3. Yeah, good. F11. No. And yeah, we're gonna do this probably a million times. You'll be doing this a lot yourself, because this is all just part of the fun. Yeah, see, go is still false. Go should equal be true. It should just keep true. Should not be false, because there is no error found. Now, if an error found, this is what it should look like. See how it turned red? That's right. That's what we should see. And then this should not be an error. There's a problem over here. Return as Boolean. Actually, you know what? Let's just get rid of this. Yeah. I'll get rid of that C. Let's see what it does. 1, 2, 3, 4, 5. Perfect. F10. Still error found. Alright. Well, this is going to officially drive me crazy. The problem with this is that even if this is right, it's going to return true. So let's do a little bit of the dim. If go equals false, then equals true. I'm actually shooting myself in the foot by doing this code. I really don't like doing this right here. GG equals false. What I'm doing is I'm just saying if go equals false, set GG to true. So then it's kind of doing the same thing, because I don't know. I'm not a fan of doing this, but I've done this before as a way to temporarily fix the problem. So we're gonna actually check GG each time, and then say because it can be false here, and then this will reset it to true, true, true. So once it gets here, it's true even though there's a false in the line. So what we're doing is we're saying if GG equals false, then set. Well, if go equals false, set GG to true. So if GG is true, that means that there was a false somewhere. A little confusing. So this is not really the best example for beginning programmers, for somebody who's looking for just a very basic example. So this is a little confusing because we're kind of checking and flagging a flag, because the flag does get reset falsely. So it's very rare. There is a correct fix to this, but I just don't have. I'm not going to do it right now, and I'll probably get it later on in one of the videos. But for now, we're just going to use this. It's a good little fix. So what we're going to do is, so right now go is true. This is going to check it, and it's going to return true. So here go stays true. So we don't worry. GG is still false. City. All right. I'll actually just start stepping over them. Sorry. So go stays true. Go stays true. Now go stays true. And GG stays false. We're fine. So we're able to actually print the address here. Now, if this is nothing, this is nothing, then we run this, and we go. Let's actually come back here. Sorry. Next statement. F11. We walk into it. Now we're going to see that go is true and GG is false, right? So perfect. So this becomes false because address.text equals nothing. So this is false and GG is true. Now GG stays true regardless of whether this is true. GG still false, still true. This is false, so we change GG to true again because it's already true, so it doesn't change. And then we come down here and say, is GG false? No, it's true because there was errors. we flag the flag. And now instead of putting that, we put error found. And now we'll see back here, error found, and then we mark the ones that are errors. So we're going to do this. Let's actually get rid of these breakpoints so we don't stop. So we'll see it in real time. Now we see that error still found. One went red, so we get rid of this one. And we put text over here, like this, right here. And bingo, there we go. Everything's fine. So we actually get the address. So we get rid of this, rerun it, and now we see the errors found. So flagging the flag is a workaround for horrible programming. No, it's actually it's not a really bad workaround, being that this is a function, and what we're going to do is we'll call this function multiple times. So we'll call it once here, but then down the road we'll probably need this function again. So we're gonna build the address, we'll pass the for text in, and then it'll return back the right address. So now, by using a function like this, where we're able to pass in for, we can then turn around and create a whole separate section for so in the event that we have address 1 and then address 2, so we want to build address 1 into a string and address 2 into a string. So we got the first set of boxes, we use this, we pass the first set of 4 boxes in, and that's going to create return 1, which would be the address 1. So then for address 2, which is going to be text box, say 8, 9, 10, 11, we'll do return 2 equals build address 8, 9, 10, 11, and that'll actually take in those text boxes and spit us out a qualified address for address 2. So the difference between a sub literally just runs code, and in this case right here, we just run the code and we set label 1 to equal whatever it is, and then that's it. It doesn't return anything. A function will actually allow us to pass in stuff, and it passes us back a result. So functions are a lot more useful than actual subs, but you'll probably end up using subs a lot more due to the fact that we're able to break off code and then use that same code, and we don't care that it returns anything. So you'll probably end up using subs a lot more, but functions to me are a lot more useful. I use functions in a lot of different things in my web services, in my dynamic link libraries, my DLLs. I use a lot of functions in there. But functions, as I find functions to be better because they allow us to take in stuff and send back stuff back over to your caller. So just a quick little recap in this one, we added more text boxes. We handled more text boxes, the text in the text boxes right here. And then what we did was we set the label to be originally just the text boxes themselves right there. So we did a variable to handle the variables themselves all into one to create a big one, and then we did the text box. Then we set label 1 to equal that variable. Then we set label 1 to equal the text boxes alone, and then we built the sub and let the sub define. We passed in the variables to the sub and let the sub set the label. And then we built a function and let the function do some verification on the text box to make sure text is there. And then if text is there, actually return back a qualified address. Otherwise, return back false. And then we actually took that return and we put it onto the text box, onto the label itself. So this one right here was a little bit confusing. It's a little bit long, but please watch this video over and over again until you get it, until you understand what we did, until you understand how we defined variables. We defined the text that goes to them, and we set the label to equal the text, either by a variable or by text box themselves. And then we actually did the return using a function for verification, and actually set the label text to be that function using the verification. So check this one out. Watch this one a couple of times. You're probably going to need to. It's going to be here probably from now until forever because I did it. I didn't steal anything from anyone. This is me, and it's my stuff. So if there's any questions or comments, feel free to ask me on Facebook at facebook.com/eagle757, Jason and Hickory, or email me at eagle757@yahoo.com, or post a comment, like, subscribe, anything on this video, and I will be sure to answer any comments, questions on this video. Next one, I do believe this was over an hour. The next one, we're going to get into some more functions and DLLs and stuff like that. So here we go.